So let's understand how Unix allows you to run certain activities in the background. By default, whenever you run a Unix command or a shell script, it runs in the foreground. By foreground means I logged in. Let's say here I am logging in. Once I am logged in, I want to run some command. Let's say it could be a command or a script. Say for example, I am running a dummy command sleep, which holds my command prompt as if I am running some command for whatever duration I mention in seconds. So sleep is a command which accepts number of seconds to sleep as an input, as an argument, and for those many seconds you can assume that the command is running. So I said sleep 10 and my program is running in the foreground. So this is what happens when you run some command in the foreground. It holds your command prompt until the execution of that command or script finishes. So in my case it was a dummy command sleep 10. The execution duration of my program was for 10 seconds. So until the program finishes its execution, command prompt is never given back. That means everything that runs in a foreground will hold your command prompt as a hostage, and until the program or the command itself runs, you can't do pretty much anything on your command prompt because there is no command prompt written to you. So if I wanted to do something else, then I wouldn't have been in a position to run because my command prompt is not available where I can start interacting with the shell, which is not there. In such cases, one may choose to run such non-interactive programs in the background. By background, I mean the program will still run as is, but it will run in the background, meaning it will not hold my command prompt as a hostage until the program is running. So I run pretty much the same job. Let's say again sleep 10. This is some valid command or script that you want to run. If I don't do anything else, it will run it in the foreground. I want to, however, run it in the background. So put an ampersand at the end of the command. So see here, my command prompt has returned. I can do anything here. My job is still running. I type the command jobs. It prints me all the jobs that I have submitted in the background for execution. And now it says that the job has finished. So instead of running the job in the foreground, which will hold my command prompt as a hostage, I can't do pretty much anything until my command execution finishes. Such non-interactive, non-printing jobs, which does not echoes anything on your standard output device, can instead be then put in a background for execution, simply followed by an ampersand sign at the end. Once I put an ampersand sign, it tells Unix that this command has to be run in the background. Now you must have noticed that it prints something. The moment you run a job in the background, it prints the PID of that process which you have just submitted for background execution. That PID can later be used to track whether your job is still running or has it finished. Or one could also type the jobs command to find out which are the jobs that are currently running in the background. You see now there's none. So when I said run it in the background, it printed me the PID. It immediately returned me the command prompt. Now once I have the command prompt, I can pretty much do anything that I want while my job is still running in the background. So I typed pwd, I typed ls, and then I wanted to see has my job finished. I typed the command jobs. When I typed it, then my job was still running in the background. After some point in time, while I was still working on some other activities, I got a message saying done, which means the slip 10 job has just finished its background execution period. And then after that I type jobs, I don't see that program any longer running in the background. At any given point in time, if you want to see the PID of the job that you submitted at the end for background execution, you can use a special variable called as $! It gives you the same PID for your last job that you have submitted in the background for execution. Typically, during your interview on Unix, they would ask you, tell me some of the special variables and their purpose in Unix. One of them is $! This is a special variable that stores the exit status of the previous command, which when 0 indicates a successful execution of the previous command, and which when non-zero prints a failed execution. Either the command or the command's assertion has failed. Another such special variable in Unix is $! When you submit several jobs, I will call them as job A, B, C and D. I submitted all the jobs A, B, C and D for background execution, which means command followed by the ampersand sign. Now whenever you type echo $! It will print you the PID of the latest job that you have submitted for background execution. See here, I said slip 90, slip 80, slip 70. All of them I have submitted for background execution. Also notice what are their PIDs. I can check those PIDs by saying multiple grep command, egrep. All of them are running. I said jobs, it prints me the jobs. Now if I say echo $! Now, it prints me the PID of the last job that I have submitted in the background for execution. So first PID was 4419, 4420, next one was 4421. But when I said after all $! It prints me the PID of the job that I have submitted at the end for background execution. I can always use jobs command to find out what is running. At some point in time one job would finish. At some other point in time the other would finish. After all of them are done, if I type jobs, it won't print me anything. So I keep on typing this thing until one of the jobs finishes. Pretty much we are see here now, one of them is saying done. The other two are still running. The other one is also saying done. The last one is still running. The other one is also done. If I say jobs now, there are no more jobs left in the background execution. If I type echo $! It would still print me the PID of the job that was last submitted for background execution. So understand this. Commands which are long running, non-interactive. Basically they don't accept any conversation. They don't establish an end user dialogue. And commands which does not display anything on standard output device should ideally be run in background. If anyways it's a long running command, it does not accept any input, it does not print anything on your screen, then why to run such a command in the foreground? Because until the command is done, I can't do anything on my command prompt. To submit a command or a script for background execution, type the name of the command or the script followed by an ampersand sign. It prints you the PID. This is the process ID which can be used to track back that particular job. Jobs command can be used to see all the jobs submitted for background execution in the current terminal. Now this is very important. Now understand this. I am opening another session as Dick. I said, who am I? It says you are Dick at PTS oblique 5. I said in my previous window, who am I? He says, you are root PTS oblique 5. Here I am root PTS oblique 4, but my current identity is that of a Dick. Remember, who am I shows you the original identity, and who am I without space shows you the current identity. So currently I am Dick, which is using the terminal PTS oblique 4, whereas here I am now, as of now, I am Dick, who is using the terminal PTS oblique 5. Understand, there's a very short statement here, but very important. Jobs command can be used to see all the jobs submitted for background execution in the current terminal only. So in both the cases, let's say here I am as Dick and I submitted a background execution job saying slip 90 followed by ampersand, and in another case there's another Dick who is using a different terminal. He said slip for 80. If I type a jobs command here, it only shows jobs which are running in my current terminal session. Whereas if I type jobs here, it shows only my job which is fired in this terminal. But if I see processes that are for Dick, I can see from the running processes for Dick user there is a slip 90 that is running. For another Dick user there is slip 80 that is running. However, one is running in PTS oblique 4, another one is running in PTS oblique 5. So jobs command will only display jobs for your session which are tied up to some terminal ID, some TTY line, some virtual circuit, and not for any other users on the system. So very important. Background jobs are terminal bound. This is even more important. So which means whenever I submit a job gets attached to a particular terminal or a virtual circuit that has been assigned for my session. In this case, for this Dick user, my job of slip 90 is bound to a terminal called as PTS oblique 4. Whereas the slip command 80 for another user session called as Dick is terminal bound to PTS oblique 5, which means if I kill my session, the job would also vanish because it's attached to a terminal. So when I log out, my terminal connection is broken. So whatever jobs were running in that particular terminal session, they would also be lost. Let's redo this exercise and understand in a better way. My job has finished, by the way, now. Before I do this, I said who. So one of the Dick session is on PTS oblique 4. Another Dick session is on PTS oblique 5. So let's understand what I mean by this thing. In one session, I am as root. In another, I am as Dick. Dick submits a job of slip 90. He also submits another job of slip 80. When he sees his jobs, he can see them. But I told you those jobs are terminal bound. They are hard code attached to a terminal. As a root, I can query sessions for that of Dick. Well, I am only interested in the slip commands. I can see all of them are running. If I kill the terminal itself, which I can see from who command, I want to kill if this particular session is killed. See what happens. I am in this window. I directly close the window. what happens to the jobs that are running then? As of now, I see that they are running. At some other point in time, those will disappear. They will never run to the completion. The moment Unix detects that the session is lost, the jobs would be removed. So they would never run until the very end. The moment Unix detects that the terminal with which these jobs were attached has been lost, if I type with who command, well, I still see that my session is running for some reason. Once this particular line from the who output is removed, you won't see that job any longer. Let's try to simulate with a direct login. Probably I might have switched, because of which my observations may have had a flaw. I am directly logged in as user 1. I said who all are logged in. I can see there's a user 5 connected at a terminal PTS/6. Now let's say, like Dick earlier, this person also submits sleep 90 and sleep 82 jobs. He can see them. Clear? I say PS. I can see the PID of my bash shell, which is my login shell. What if this shell itself gets killed? Prior to that, let's grep for it. I can see both the commands are running. What if the session itself is lost? I am deliberately killing the bash shell of that user. The moment I killed his bash shell, the window has disappeared. If I check now, I still see it, but at some point in time, automatically the jobs will disappear. Now you see here, I don't know if there's a difference in the way the command output appeared here and here. Understand, when the terminal was here, what was my output? This was my command. These were the PIDs of that particular sleep 80 and sleep 90, sleep 90 and sleep 80 respectively, which was the PPID bash shell. So who was the, or which was the parent process for sleep 90 and sleep 80? A PID 4600, and 4600 PID was that for the bash shell. If I check, see here, it's still running, but now who is the parent? Init. PPID column is showing as 1, and PID of 1 is associated with the init program, the first process to start in Unix. Earlier this job was terminal bound. Later this was showing as question mark, like a daemon. I told you, user processes show some terminal value, daemons do not show a terminal value. So at some point in time, the job will cease to exist. Background jobs will cease to exist if the session itself is closed, meaning they would terminate. So automatically the job will be lost. So how do I prove this? Because this wasn't a significant conclusion here. I don't know whether it has finished or whether it was terminated at the end. Let's try one more time. As user 1, I am writing a shell script. I am simply saying so see what this script is doing. It prints a message into a file tmpbkg.log. Then the script goes for a sleep of 90 seconds. After 90 seconds, it again prints a message into the same file. Again it sleeps for 90 seconds. Now instead of sleep, it is like a programming logic that you might have written. So I don't have a programming logic which can run for 90 seconds as such. So I put an instruction for sleep. Then I said echo what is the time now, and lastly end of program message. Let's see what happens if I put this program in the background for execution. I said this thing followed by an ampersand. I see that the program is running. This is the PID, this is the PPID. Now if I see what is this PPID, this must be for the command shell of that user. So if I type PS, you see bash is the PPID 4452. Which I don't see it here for some, no, there wasn't anything as such, right? I saw a bash -f. It is prompted as a bash script, by the way. So this seems to be my parent one. So if I kill the parent, see what happens. My window has terminated. Let's see what my log shows. The program was started at so and so date and time was the first line. Next instruction was to sleep for 90 seconds. Next instruction was to again sleep for, print a message and sleep for 90 seconds followed by end of the job. Let's see if it can print it or has my job really finished. If I check, depending upon the PPID of my program which was displayed earlier, well, I lost it, looks like. So let's keep on doing. See, my job is running as of now at least. I want to see who is running it. See, the command that is in progress is still running. And this is the shell that is making it run. The terminal bound has been removed. Instead, for my bash shell, it is showing the parent ID as init. So now I should no longer see anything into this one. It is still showing sleep 90. Once I am done, probably I shouldn't see any more messages into the file. Now if you run a job in the foreground, it can be moved to a background execution. Understand what I mean by this thing. I am logging in as Dick. I submitted a job and later I realized I should have run it in the background. Now how sooner it will return me the command prompt after 90 seconds. I submitted and then I realized I should have put an ampersand for background execution. See what one can do. Press Ctrl Z. Putting a Ctrl Z will suspend the job. I didn't put Ctrl C. Ctrl C will terminate it. Ctrl Z will stop it. Now my job is in a stop status. You can see if I type jobs, I can see it's in a stop status. Well, now it's a question. What do you want to do? You want to put it in background or you want to bring it to foreground? If I want to put it in background, I must type BG. If I type jobs, see here what it shows now. So if you run a job in the foreground, it can be moved to background by pressing Ctrl Z on your screen. Ctrl Z will suspend the job. And once suspended, you can type the command BG to put that job in the background. So it's running now. What if I want to bring it to foreground again? Type FG. It's back into the foreground. Again I realize there's no fun having it run in the foreground. Again press Ctrl Z. Now if I say jobs, well, by then it has already finished. By then it has already finished. Again, if you would have wanted to put it in background, you could have pressed Ctrl Z. The job would have been suspended. Once suspended, you could have again put it in the background for execution. Now understand what is the problem with background jobs. I submitted a long running job, let's say, to perform a backup of my database. The job, let's say, runs for 2 hours. My database is huge. It takes a backup of that database, copies the files and puts it in a backup location. So this is a scheduled job. There is no interaction. It does not print anything on my standard output device. So I said /home/disk/backup my database.sh is the name of the program. Clear? It's long running. Once I submit it, it is going to run for 2 hours. Since it does not accept any user input, since it does not print anything on my standard output device, and it's a long running job, wouldn't it be a wise idea to put it in background for execution? So let's say I added an ampersand. I submitted it for background execution. After 1 hour, automatically my putty session got terminated. Automatically, because there was a network disconnection or there was a program error in putty on my Windows machine. So my session got disconnected. What will happen to my job? I told you, all jobs that you submit in background are terminal bound. So the moment my session is disconnected, my job would also be terminated on the server. So it will no longer exist. Now why it won't exist? So there is a concept called as a zombie process. So consider a case. I have a parent process, say bash. Bash is my login shell. Means the moment I logged in, some shell was assigned to me. How? I said ps-f. This is my bash shell. This is the command prompt where I type the commands. You see it is terminal bound. You see it as a parent process with the PID as 4763. Now if I run some command here, for example slip20, and again I say ps-f, you see for slip, who is the parent? 4764. 4764 is indeed the PID for my bash shell. If I kill my bash now, what would happen to the slip program? Now see here one more time. But if I kill it, there wouldn't be any observation window left for me. So let me start another session. I logged in as user 1 and I typed, first I typed ps-f. As of now there's only bash that is running. I said sleep 100 seconds. Again I type ps-f. For the sleep command, who is the parent? 5492. 5492 is the PID of my shell. As of now, whether it's bash or sleep, both are associated with a terminal. What if I kill the bash shell itself? See, my window has disappeared. I said ps-ef grep sleep. Now this was the process. See, who was the parent earlier? The bash. But now the bash program itself is no longer there. So who is being shown here as the parent? Init. If I type the top command here, see here what is the process ID of init? That init is having the process ID as 1. Clear? So parent process bash, which was my login shell, with PPID, let's say 1 2 3 4. On the command prompt, I started a program which has PID as 5678 and PPID as 1 2 3 4. If parent process exits without waiting for the child process to finish, the child process would attach itself to init, which has a PID equal to 1. Such processes are called as zombie processes. So in Unix, such processes are called as zombie processes. So what is a zombie then in short? A parent spawned a child. The child started its execution. Normally, the parent has to wait for the child to finish. But in this case, the parent process never waited for that child to finish its execution and it abruptly exited. So now a child has a missing parent. The child will find a new parent will attach itself to the process as init. So who would be the new parent for that process? Init process. Such a child process is called as a zombie process. Clear? Now we have realized that when you run a command in the background and the window itself gets terminated, the job would not run to its completion. In such cases, one can run the command with a no hup option. No hup is an abbreviation for no hang up. No hup continues to run the job in the background even if the session is terminated. No hup jobs are not associated with any terminal. So simply if I put a command followed by a background symbol, background sign, ampersand sign, the job is terminal bound. So it runs with an attached terminal. If the terminal itself is closed, my job would also disappear. But if I run like this, no hup followed by a command followed by ampersand, then no hup will continue to run that particular program even when my session is destroyed. Clear? The output generated by the command is captured in nohup.out file in your current working directory. If there is any output generated by this thing, it will be captured in a file called as nohup.out. See it here. I am again logging in as user 1. I am editing and I am removing the redirection part of it. So it will print everything on my standard output device. Instead of 90, which is very lengthy, I would say short sleep time. Now instead of simply running and this thing, I would say no hup followed by this thing. Clear? When I submit a job, see what it says? No hup appending the output to nohup.out. There was again a second sleep for 10 seconds. Clear? Finished. My program has finished now. So understand what I meant by here. The output generated by the command is captured in nohub.out file in your current working directory. Wherever you were at the time of typing the nohub command, in the same directory there will be a file created for you called as nohub.out, and whatever program you have submitted with no hang-up option, the output generated by that command would be captured in nohub.out file. Clear? So background execution makes Unix even more powerful, because now I have ultimate flexibility of opening only one window and running several commands from the same window. People say, how do I make my job non-interactive? Because you said the job has to be long running. Then you said the job also has to be non-interactive. And then you also said the job should not print anything on the standard output device. See how I can make such a job. Here I am as root. I am submitting a job. Find in root all the files named star.txt wherever they are. Now it's long running. Find will take a long time to find all the files. It's non-interactive because it never asks me any input as such now. But the problem is it still prints something to the standard output device. Then I can redirect the whole thing to and then put it in the background for execution. See here, it's long running. It's still running. It's non-interactive. It does not prompt me to type anything. And it does not print anything on my device. It's all being redirected to a file instead. See if my command, it's still running. If I check the output of that command, as and when it comes across, it is printing the paths of those files in the output I have redirected. This was my command. Right? I said jobs. See what it says now? Done. Now the program has finished. If I check, this is the output of my command. If I check here, these many txt files it managed to find. Clear? So you can make a job non-interactive, and if it prints anything on your standard output device, you can always redirect it. People say, what if I don't redirect? Then there is no use of putting it in the background for execution. See here. Is my job long running? Yes. Is my job non-interactive? Yes. Will it print anything on the screen now? Yes. Is this a suitable candidate for background execution now? No. See what happens if I still make it in background. I said, see, it's not running it in the background. It's all done. It still prints everything on my standard output device, causing a lot of problems on my screen. Similar way, if I say test bkg and I put it in the background, the problem with this script, it still prints me something on the screen. I put in the background. See here, it's running. I am doing my job. It's in the background. I am still doing my job. I am still doing my job. I am still doing my job. But see, again the message pops up. Again I am doing my job. 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 But again the message pops up. So that's why I said don't run the jobs which print something to your standard output device in the background, because they unnecessarily interfere with your working. They will keep on printing something or the other periodically onto the screen, and that's what doesn't make them a good candidate for background execution. So 3 qualities you should look for background execution. It should be long running. It should be non-interactive, and it should not display anything on your standard output. If all these qualities are qualified for a given job, then such a job should be run in background. Let's understand the Unix environment and the variables. Now this is one step closer to our shell script discussion. Unix allows you to set your own environment using something called as environment variables. Environment variables by convention are in uppercase. It's not mandatory, but Unix says by default all the environment variables that we declare or allows you to customize, they are all in uppercase. There are some standard variables, set of variables such as path, host name, home, mail, term, LD library path, which are automatically set for you. So here I am. If I type the command env, I can see all those variables. I said hostname, shell, terminal, mail, path, home, log name for that matter. So these variables are automatically set for you. If I check for another session, the values would be different. I said what is the home? For this user it says home is home user 1. When I said what is my home, it says it's home Dick. I checked what is my mail dir or mail file for that matter, it says var spool mail user 1. When I see it here, it's var spool mail Dick. I check what is my log username, it's Dick. I said what is my username, it says user 1. So multiple environment variables are there, out of which these are some of the standard ones which are automatically set the moment you log in. Apart from the standard set of variables, an user can define his or her own variables. If I want something to be set by default, I can set something on my own by saying export variable name is equal to value. So I can set some variable like this. And then if I type env, you see there's a custom defined variable now. So some of them are automatically defined for you. Others for customization purpose can be defined by the end user as well, using this convention export variable is equal to value. Now let's understand what are those standard set of variables which are by default there. The first one is path. This is a very important variable. If you mess up with this one, see what it says. From the environment I have filtered the line that begins with path. Path is one of the standard environment variables. I said path is equal to something. So some path has been given. So understand what is the significance of the path environment variable. Is set of searchable directory locations separated by colon. Let's see. This is one directory separated from the other using a colon. So it's a set of searchable directory locations separated by a colon. What is the purpose? Where Unix would attempt to find a given command or a program. So what is the purpose? When you type a command, How does Unix knows where the command is? It will go into those searchable locations and will try to find it out. Understand? Here I am user 1. I said from the environment variable grep for path. So this is my current path setting. Now if I type a command test underscore bkg dot sh, see what it says? Command not found. But I want to see, isn't there a script with the name? Clear? So understand why it says command not found, although it is present in my current working directory. When you type a command, Unix checks for that command's executable in all the directories in the same chronological order as you have mentioned in the path environment variable. So is this test bkg.sh present in this directory? No. Is it in this directory? No. Is it in this directory? No. Is it in this directory? No. This one? No. Is it in home user1 bin directory? It's not in home user1 bin. It is in home user1. When it looks for test underscore bkg in all these directories in the same chronological order and cannot find the name, then it displays your error command not found. Clear? Now what should I do? I should in such cases mention the complete path of that program. I know where it is. Unix couldn't find it for me. Then I am saying it's in home user1 test bkg.sh. Now there was no confusion because I have given the direct path to that particular program. Path can either be given in an absolute manner the way I typed it, or it could also be the relative path. In this case I have typed it in an absolute way. Consider that I would have been one level up. I want to run test bkg.sh. This time I don't want to mention absolute path. I said dot slash user1 followed by this one. So dot indicates current working directory, which is slash home. Inside that there is a folder called as user1, and in user1 there is a script called as test bkg.sh. If I run it, this time Unix has no problem finding that particular command. So but the problem now is, every time I want to run a command, I need to mention the complete path of that command, either using an absolute path name or using relative path name. Do you need to do the same thing for ls command? See here. I said which ls? ls comes from which directory? Bin. I said ls, it shows me everything. Now why I never have to mention the path for ls? The answer is the bin directory is automatically there in the path. So whatever directory is in the path, if the program comes from that directory, you don't have to mention the path. So what if I don't want to mention the path for my program? Include that directory in the path variable itself. So see how I do it. I said export variable equal to value. So I said path is equal to this whole value including home user1. Clear? Whatever was the existing value, I appended to it home user1. Now I said without mentioning the path, just the command name. See here, this time it does not have any problem. So what it must have done in the background? When I type test bkg.sh, it checks what is the environment variable path set to. It then checks for the existence of that program in here. Not found, not found, not found, not found, not found, not found. But when it goes here, it comes across the command home user1 test bkg.sh and it was able to run it. So understand the significance of path command. Another example, I create this directory. It was not there. I go here and I say I have written a sample program which prints just only one liner. I said chmod make it executable. Where I was? Home user1 bin directory. Now I am in home user1. I create another program with the same name. But in a different directory. I also make this program as executable. Now when I say 1.sh, see where from it is running? From bin. Now why it is running from bin and not from here? That is because of the order of directories that I have mentioned in my path environment variable. So if I say env path, which one comes first? And later on comes which one? This one. So when there are two programs with the same name in separate directories, which one it will pick up? It will pick up the one that comes in the first searchable location. Now see what I am doing. I have removed that program. Now I say one more time 1.sh. So it is caching. If I log out and log in, probably it should be able to find a correct one. It's because of caching probably that it is still searching the one from here and it says there's no such file or directory. I said sync and then I want to run. It still says that one. I go here and I said see here now. Now why it was erroring out here? Because of caching. It cached that there was a file here, but when I try to run it, it's not able to find it. But in a separate session when I do that, it managed to find that file and this is 1.sh, but where from it is running? Home user1. Earlier it was running from home user1 bin directory. So understand the significance. Is a set of searchable directory locations separated by colon, where Unix would attempt to find a given command or a program. When Unix fails to find a given command or program in those directories, an error is returned saying not found. Here I typed it for if config. Let's say as a simple user, if I type if config -a, see what it says? Command not found. Because if config comes from sbin directory and sbin directory is not included in my path. You see here if I say echo $path, there is no sbin directory included here. And if I say sbin if config -a, then it works. Because this is where I mentioned the complete path. So it checks first, is that if config program anywhere here? If not found, then it says command not found. Command not found simply tells that whatever command I type was not part of the directories which I have set in the path environment variable separated by a colon. And that's why Unix failed to find it. How to overcome? Mention the complete path. If not, mention the directory itself into the path. so that next time when it searches, it never comes across this error again. So to run such commands, you must include the directory in which the program lies in the path variable, or type the complete path of that program either in an absolute format or in a relative format. The changes that you do to the values are only visible in the current session. People say, what would happen if I exit? So I typed if config -a not found. I knew why it was not found, because it comes from sbin directory and sbin directory is not there in path. I said export path equal to $path : sbin directory. Now I type the command, it works because I included sbin directory in the path. I exit. I again logged in as user1. I said echo $path. Sbin directory is again not there. So see here, the changes that you do to the values of a given environment variable are only visible in the current session. Once I close my current session and I relog in, all values will again go back to the default configuration. The order of the directories does matter, I told you earlier. So 1.sh, it picked up from the directory which was in the search path listed earlier than the other directory where again one more 1.sh was present. Once a program is found in some directory, Unix does not searches further. Once 1.sh was found, it never goes to the next directory to find out whether there is one more 1.sh elsewhere. The first directory where it is found, it will run it from that particular location. As a standard practice, add standard directories first and custom directories later in the path to avoid accidents. To avoid accidents, what I said, standard directory should be first and custom directories should be at the end. People say, what is the concern with this one? See here, I am creating a file called as ls. ls is also a command. Now I said echo I am a virus. This is just for you to understand. I said chmod, mark it as executable. I said ls, it prints me the correct output. Why it prints me the correct output? The answer lies in which ls. It says where from the ls is coming? Bin directory. Now I was wondering why it is coming from bin directory and not picking up the one that I created. I said echo $path. Bin directory is listed, whereas my directory where this program is not listed. So I said export path is equal to standard path followed by home user1. Right? I said again ls. Again it is displaying me the correct output. I said which ls? It's from bin ls. This is what I mentioned. Put standard directories ahead of custom directories. People say, what would happen if I put a custom directory before? See what happens now. I said export path equal to home user1 first, followed by the standard directories. Now I said ls. Clear? So it's not picking up the correct ls now. Now I said, why is it not displaying me the output of ls? I said, which ls? It says from where it is picking up the ls? Home directory ls. Now this was quite evident because I printed something. Now consider a case. Typically this happens. I said vi ls. I open one more session. I export path by including my home directory first, followed by standard directories. I said ls, it does not displays me output. Why? Because in the ls there is no instruction. It's simply marked as a 0 byte executable file. See here how. So this is my program ls. It's of 0 byte. If this happens, you will keep on searching. Why is it my ls is not working? This has happened to a lot of people in real life. They said ls, nothing is working. They said dir and it displays everything. He said, why is my ls command not working? Because your ls command is not the standard ls command. Your ls is a 0 byte virus. Clear? This is the reason why I said, as a standard practice, add standard directories first and the custom one and custom directories later in the path to avoid accidents. So this is an accident. When I say ls, sorry, this was the correct session. This is the wrong session. When I say ls, nothing is happening. Because it's not the standard ls program. The quickest way to say is which ls. And now I knew, oh, it's not the standard ls program it is picking up. It's the some dummy program it's picking up from my home directory. I said rmls and now I say ls. It says not found. Why? Caching. If I terminate my session now or after some point if I check, if I type ls, it will display me the correct value. Now as of now it's coming out of a cache. I said echo $path. I don't change this path. I will keep it as is, but in a fresh session. I said ls, it is still working. Although the home directory is there, because I removed the virus program itself, the one that was causing accidents. I said ls, it is still showing me the cached output. So it's better to say echo $path equal to echo path equal to $path followed by my custom directories. Good way to set the path. It's not a good way to set export path equal to my current directory followed by the standard path. So your standard path should be first and custom path should be at the end to avoid accidents. So if there are any standard programs conflicting in the name, it would pick up the standard ones instead of picking the custom ones. Otherwise I can always mislead people by changing the path. I could have made hostname command ka output to show something, and whenever somebody types hostname, he displays a different hostname. So always ensure that custom paths are put at the end. Next one variable is home. This environment variable points to your home directory of the current user. We do not change the value of this variable. See here, I said echo $home. This is my home directory. People say, what if I change this? It allowed me to change. I go to etc. What happens when you type cd enter? It takes you to your home directory. I said where I am. Is this my home directory? No. My home directory should have been /home/user1. So although Unix allows you to change the value of this variable, it's not a read-only variable. It allows me to assign a different value, but I strongly discourage you from doing this, because by default your home directory is set to whatever it was, home username. If you change it to elsewhere and you then type cd enter command to go to your home directory, it will not work, because that cd without any argument actually examines the value of home variable, and whatever is the directory it takes you there. If I change the directory itself, nothing will work. So don't change this. The environment variable mail points to the user's mailbox. This is the file where all emails are stored. So I said, so which is my inbox? This is my inbox. All my mails are stored in this mailbox. As of now, 0. I am opening a fresh session. I said what's there in my mail file. As of now it's of 0 bytes. But if someone sends me an email, that mail will be temporarily captured in this file. See how. I open a duplicate session. Once I am done, I have typed a message. At the new line, type dot to end the message. It says, do you want to send a CC to anyone? No. That's it. Mail was sent. So where will be this mail captured? In the inbox of that user. At some point in time, see, you get a message. See what it says? You have a new mail in this file. See here. Earlier the file size was 0. Now it is showing some size. If I cat the file, see, I can see the mail format from whosoever at whatsoever and followed by my message and whatever. So my mails are stored temporarily in the file. How do I check a mail? You don't cat a mail file, right? You instead read it from the inbox. So I type mail. As a DIC user, I type mail command. I see there is an email from user1 at whatever machine. I type 1 because that's the number associated by email. N to indicate it's a new email. I typed 1 and I see the message. I type Q to quit and then I check the file. See what is the file size? The file size is 0. That means whatever mail was there, I already read it. It's no longer a new email. So all the new emails received by the user are kept in the file where spool mail username. And how does my Unix knows? Because of the environment variable. Points to the user's mailbox. This is the file where the new emails are stored. Once the email is read by the user, it's removed from the file. So it's then removed from the file. It's no longer there for you to read now. Term. Unix supports multiple terminal types. Each terminal has its own characteristics. You can set a desired terminal such as Xterm or VT100 or SANE, whatever. Each terminal supports multiple settings which can be done using stty-a command. See here. Now I am talking about the terminal settings. So that's why I didn't record that section, because I don't want people to practice which I don't want them to practice in real life, because it's not ethical. So Unix supports multiple terminals. I told you what is the concept behind a terminal. Every time you establish a SSH session to your machine, Unix assigns you a sudo terminal. That terminal, whichever it is, there is a vast choice of terminals available to you. But whichever is your terminal, let's say in my case I am using a Xterm. Somebody might use some other terminal type, like for example he might say export term equal to VT100, and then I say echo dollar term. He is using a different terminal type. A terminal type is an experience of you interacting with Unix. People say, what do you mean by experience of interacting with Unix? You type stty-a, you will come to know. Speed, this one, baud rate. How many rows are there on your screen? 24. How many columns are there? 119. What is the default line size? How to interrupt a command? By pressing Ctrl C. How to quit a command? If a program is running and I want to abruptly terminate, so it says Control / quits from a program. How to erase? Control ? Which is nothing but a /. How to kill the command that I have typed? I have typed a long command. How do I erase this? Don't say backspace too many times. Instead you can say Control U. See what happened? It erases the current line. End of file is by Control D. End of line is by enter, whatever. So it sets the multiple terminal characteristics. Each terminal have its own language. If I go and check it for a Xterm, it might use a different set of characters. If I want to customize something, by default in Korn shell, this is what one might expect. stty erase and then I say stty-a. See what is my erase? Control H. This is by default in old Unix. If you want to erase a character, backspace was not there, so backspace will not work. How to erase then? Control H. How do I know which is the character? Then you can type stty-a. Stty-a means show me the terminal type properties. So my terminal type is VT100 in this case, and erase character. See what happens now. I said I want to erase करना था, मैंने backspace किया तो देखो क्या आ रहा है. How should I erase now? Control H. I said Control H, Control H, Control H, Control H. To erase this. Now if I type backspace, 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 backspace is not working because I changed the terminal type erase character from backspace to Control H. Now I say Control H, Control H, Control H, Control H, Control H until everything is erased. Clear? So terminal type sets the user experience with Unix terminal. So those properties which one can change are these properties. How many columns should be there? How many lines should be there? I said stty. Before I do this, I said top. See how big output I see, entire screen. Now I said stty rows equal to 10, not equal to, rows 10. Now I said top. See how much output I am seeing? Only 10 lines. I said stty. One such variable was columns 20. I said top. See here how much output I am seeing now? Only 10 rows by 20 columns. So these are nothing but the terminal characteristic types one can set. So term Unix supports multiple terminal types. Each terminal has its own characteristics. You can set the desired terminal such as Xterm or VT100, or there are multiple actually. Each terminal supports multiple settings. You can obtain those settings by typing stty-a. LD library path is another environment variable. An executable program needs multiple library files, which are .so files with the extension .so in case of Unix, for successful execution. For example, see it here. I logged in as Oracle. Then I set my environment file, if at all it is there, db.env. I said env grep ora. So I set multiple environment variables, Oracle base, Oracle home, and whatnot. Also LD library path has been set. If I say there is a SQL Plus program, you have all gone through the SQL course. So you log in by saying SQL squad tiger. Now understand which is SQL Plus. It comes from Oracle home bin directory, SQL Plus. Now is this a standalone program? No, it requires a lot of libraries. How do I know? Type LDD followed by the name of the complete path of that program and see how many library files are required by this program. Too many. libsql.so, libclntsh and whatnot. My database is running, so I won't show you any destructive operation here. But if I move this file elsewhere, my program will not work. Now why it will not work? Because my LD library path says where to search for those libraries. In Oracle home lib directory. Let's see if this library is there. See here, there is a library file with the name .so. If I move it, my SQL Plus program will be unable to find that one. And if it is unable to find a library, my program will not run. So understand what is LD library path. An executable program needs multiple library files which are .so files for successful execution. The searchable list of directories where the libraries can be found, which is separated by colon, is what you assign to the LD library path. A .so file in Unix is equivalent to a .dll file in Windows, dynamically linked library. Assume that there is a program called as first, which requires a library file called as library1.sh, .so, which is present here. I am unable to run the program first because it cannot locate the library file library1.so. Then you should set LD library path equal to whatever is the current setting plus on top of that the directory where that so file is present. Now once you run the program, it will be able to find the directory. So path is for executables. LD library path is for library files. Basically both are searchable locations where either one can find an executable or one could find a library file. To print your entire Unix environment, one can type env command. It prints all the environment variables that have been defined. To make the environment changes persistent across sessions, add them in the appropriate file. I told you earlier I defined a variable export my name is equal to Khan. So variable name is my name is. value is Khan. So if I disconnect and reconnect again, will that environment variable be there? No. It is gone. It was only visible for the current session. What if I want to see it next time? Then depending upon your shell, put the entry of that variable in one of the file. If you use a Bourne shell or a Korn shell, put the entry of that variable in home directory .profile. If it's a bash shell, then put it in a .bash profile. See here which I am using. I said PS, which shell I am using? Bash. Then where should I put the value? In .bash profile. Where it is? In my home directory. So I said .bash underscore profile. Remember, it's a hidden file because the name starts with a dot. Then I put a variable saying I logged out. Next time when I log in, I said env. See here why it is persistent now even after logging out, because I added it into the persistent configuration file .bash profile if my shell is bash, and in .profile if my shell is Bourne shell or a Korn shell. Depending upon that, my variable would be visible. Clear? So we'll stop here for the session. Starting tomorrow, we would start writing shell scripts. So that's it for this session as of now.